Here we have 2009, question 2, part A. Relative velocity question where we have an intersection. So let's have a little look at our two vehicles approaching the intersection. Cars A and B travelling along straight roads, A at 15 meters per second east, so 15I, B 20 meters north, 20J, and we're told at a certain moment they're both 800 from it. So let's just get a little bit of diagram down for this. So there are our roads. B is going at 20 this direction. A is over here, going at 15I, of course 20J. Alright, I like to put my distances in different colours so I don't confuse them with speeds, so they're both 800 at this particular moment in time. Now we're looking for the shortest distance between the two cars. So what we're going to do is we're going to put one of them at the intersection to make this a little bit easier, and then we're going to figure out the relative distances. So B is going to hit the intersection first in this one. So B gets to intersection. How long? Well, it's got 800 meters to go at 20 meters per second. And T equals 800 divided by 20 equals 40 seconds. All right. A travels 15 meters per second by 40 seconds, and that is 600 meters. Therefore, 200 meters from the intersection. Now, that makes things a little bit easier. So we'll draw another diagram over here of that. So there is our roads. B is at the intersection. A is only gone 600 meters out of the 800, so it hasn't quite got it yet. So we'll zoom in a little bit, and we're going to put it 200 meters from the intersection. And there's A. Now, at this point, we're again going to make our lives easier by stopping B. And we're looking at the velocity of A relative to B. Now, you know the velocity of A relative to B is the velocity of A minus the velocity of B. That's one of those little things you have to know. Little box around that. Definitely, absolutely have to know. In our case, that's simply going to be 15I minus 20J, and there we have it. All right, it's about as easy as it gets. We're also going to need to know the magnitude and direction of this velocity, though, because we want to be able to draw it over here. What's A doing? Okay, so we know that it's going to be something like this, going across by 15, down by 20, and how big is that side going to be? And how big is this angle alpha going to be? Well, the magnitude equals the square root of 15 squared plus 20 squared. Square root of 625 equals 25 meters per second. All right, this is straight out of your junior cert trigonometry. Again, really worth knowing. 25. Well, what about our angle? Our angle, well, the tan of alpha equals the opposite over the adjacent. So 20 over 15, which means that alpha equals tan inverse 20 over 15. And I think we'll just fit this down here. 53.13 degrees. All right. So now we know this, we know our magnitude, and we know our direction. So we can come back up here. So A is going to be going down like this. I know it's not 53 degrees, but bear with me. At 53.13 degrees ish. At 25 meters per second. So, part 1 here is looking for the shortest distance. That is going to be this distance here. So, let's call this x, so we can talk about it. Now, we want the shortest distance, so part 1, shortest distance is equal to, of course, not AX, it's BX. There we go, the distance from B to X. All right, well, we know a few little bits and pieces here. We know the distance here, and we know the angle. So what we can say is that the sine of this guy, sine of 53.13, equals this side over this side. So equals BX over 200, which means that BX equals 200 sine 53.13. And BX then, if you put that all in, is 120 meters. If you're getting slightly weird rounding errors, don't be afraid. When you actually originally did this, it's 53.13 and a whole lot else. Store that in your calculator, recall it up here, job done. All right, now what's happening in part 2? How far from the intersection when they're nearest to each other? So we kind of need to come back to our reality one here and figure out at what point does this magical nearest distance happen? Well, if we knew the distance here and we have the speed, we can figure out the time when it happens. So we find time at the shortest distance. That's the key to finding this whole thing. All right, well, I'd love to know what AX is. So we know the cos of 53.13 is AX, the adjacent, over the hypotenuse, over 200. So AX is 200 cos 53.13. And you work that all out, and that is going to come out to 160 meters. Okay, useful. Now, time at AX slide this slightly, there we go. Time at AX, well, we're going at 25 meters per second, traveling 160 meters, so 160 divided by 25, and that's going to be 4.8 seconds. Be careful. So I'm just going to get a little bit of space over here to do the rest of them. Therefore, the total time to get to AX, remember this isn't time equals 0. Okay, this is t equals 40. Total time to AX equals 40 plus 4.8 plus equals 44.8 seconds. Now that we have that, the rest of this isn't too bad. So let's see about A. A at t equals 44.8. A went, well, it's going 15 meters per second. A travels 15 by 44.8, and that equals 672 meters. Therefore, it is 800 minus 672. It hasn't quite got to the intersection, and that is 128 meters from the intersection. B it'd be squishy to get this one in here. So B travels 20 by 44.8. So B is going to travel 896 meters, which means it's going to go past the intersection, and you can realize therefore B is 96 meters from the intersection. So total distance is 128 meters from the intersection and 98 meters past the intersection. There we go.